This is summer 2016, question 4, catch-up. So this function catch-up is going to take in two linked lists of integers, link1 and link2, of the same length, and it's going to mutate the linked list with the lower sum by repeatedly inserting 1 at the end until the sums are equal. And we're going to see the doc tests for some details. Great. So here's our example. We have a linked list of 1, 3, 5, 7, and 2, 4, 6, 8. So the sum of the first linked list should be 16, and the sum of the second linked list should be 20. And when we call catch-up on odds and evens, then we get 4 ones added to the odds linked list, because that's 4 shorter in terms of sum. So looking at the skeleton, we have two parameters, sum1 and sum2, and two linked lists. And we can also see some recursive calls and not that much space for iteration, at least in terms of computing the sums. So the sum1 and sum2 probably are just going to keep track of the sums. And outside, you see that this recursive call is made to our helper function. And the reason this helper function is there is just to keep track of the two sums. So let's start by just making that call by calling helper on link1 and link2 and initializing both the sums at 0 because, well, there isn't anything to add yet. Let's also draw our sample inputs. So 1, 3, 5, 7. And 2, 4, 6, 8. So then there's an assignment to sum1 and sum2. I assume just updating sum1 and sum2 with maybe the first value in both of these linked lists. And then some if statement that has a loop inside. My guess is that this if statement is checking if we're at the end of one of these linked lists, or both of them since they're the same length, and whether we are adding the ones to whichever list, because there's this variable lower, which maybe just finds which linked list has the lower sum, and then iterates through and adds a 1 to the end repeatedly. So we can first just start by incrementing sum1 and sum2. So sum1 can be sum1 plus link1 dot first, and sum2 can be sum2 plus link2 dot first. Usually, if this if statement is false, then we just want to call catcher to continue computing the sums. So catcher on link1 dot rest, because we've already added link1 dot first to the sum, link2 dot rest, and sum1 and sum2, which are updated sums. So for example, we'd initially call our function with these two pointers to link1 and link2, and sums would be 0, right? Sum1 is 0 and sum2 would be 0. Then we'd increment both of them, and then we'd call catcher again, and we'd move both of these pointers to link1.rest and link2.rest. And we'd also increment the sums. Sum1 would become 1 and sum2 would become 2. That's because of the numbers 1 and 2 here. Great, we do that a couple more times. So I'd move these red arrows along again, and my sum would then be 1 plus 3 and 2 plus 4. So 4 and 6. And then finally, I can do it again because I can add the 5 and the 6. So that's 9 and 12. And now we're at the end. In this case, we still want to add the 7 and the 8 to our sums because they do they are part of the sum. So 16 and 20. But then maybe now, since we actually have the final sums, the ones we computed initially, now we can do that like if statement. We want to go into the if statement, figure out which linked list is smaller, and then add ones to the end of it. So if, well, we're at the end because we've added the last one. So if link1 or link2 really dot rest is link.empty, which means there's no more elements in link1. And since they're the same link, there's also no more elements in link2. Then we figure out what the lower of the two lists is. And we have this hint here. You may need the ternary operator, expr1 if cond else expr2. So this allows us to do like a mini if statement in one line. And it reads mostly like English. The lower list has to be link1 if some condition. Otherwise, the lower list is link2. What condition? Well, it's link1 if sum1 is less than sum2. Right? If sum1 is less than sum2, then link1 has the lower sum, and that's the one we need to be adding the ones to. All right? Now let's do the actual process of adding the ones. So there's some for loop, which indicates to me that we'll iterate for the number of times that we have to add a 1. Because in each iteration, maybe we add 1, 1. So the number of times, well, in the case of 16 and 20, we want to add 4 ones. So the number of times is just the difference between the two sums. So sum2 minus sum1. And that could be negative or positive. So we just want the absolute value. And since we want to iterate that number of times, well, we can use range for that. And the last thing is, how do we actually add this one, right? And we're just mutating, so we really don't care about like what ends up happening to like both of these like arrows that we have, as long as we end up adding some ones. So in this diagram, in order to add a 1, what I would do is I'd get rid of this x in my that was initially link.empty and say draw an arrow to a list with 1. Right? That's my first step. So I want to say link1 dot rest is equal to some new linked list whose first element is 1. So link1 dot rest is equal to some linked list whose first element is 1. Great. Then, if I had just left it at that line, well, the next time I'd say, okay, link1.rest is equal to a new linked list with 1. But what that would do is just erase this pointer and do the same thing again, right? However, the one that I want is actually a 1 here. So, well, I could just move this red arrow along. So this could be here. So now link1 points to the last thing in link1 once again. So I could say link1 is equal to link1 dot rest. And what that would do is just add, move this red thing along right here. And then in the next iteration, we could add a 1 here. And then we could move this red thing along again. And then in the next iteration, add a 1 here. I'm having trouble figuring out what goes in this last blank. So if you'll excuse me 1 second, I'll just glance at the answer key. Okay, looks like we don't actually need the third blank. And I made a slight mistake here. Instead of using link1, which was the lower list in our case, we actually want to use the lower list. That's my bad. But turns out we don't need the last line. All right, everything else looks good to me. Great. Yeah, if you have any questions, feel free to leave them on Piazza.